Welcome to Borishal Cadet College. I am SM Atikur Reza, lecturer, Department of Mathematics, Borishal Cadet College, Borishal. Boys, I hope that you are well by the grace of Almighty Allah. Due to Corona pandemic, we could not take our class in our classrooms. I have to take our class virtually. Now I will take your higher mathematics second paper class for class 12. Today's topic: motion of a particle moving in a straight line or a plane for chapter 9a. Boys, motion of a particle moving in a straight line or a plane is a part of dynamics. Mechanics is a branch of science which discusses the behaviors of objects and the changed characteristics of objects as a result of applying force on the objects. Dynamics is such a branch of mechanics which discusses the characteristics of acting forces on dynamic objects. It is divided into two branches called kinematics and kinetics for its theoretical and informative differences. According to English mathematician and philosopher William Kingdon, dynamics is the doctrine of created mystery of motion. In the 15th century, reviewing the characteristics of pendulum and falling objects, Italian scientist Galileo discussed and came to conclusion that motion of an object becomes forceful under accelerations of a certain value of the object and proportional to time. Learning outcomes. At the end of the lesson, you will be able to know about distance and displacement, about velocity, get idea about acceleration, how to find resultant of several velocities, magnitude and direction of the resultant of two velocities. What is distance? Distance is the total movement of an object without any regard to direction. We can define distance as to how much ground an object has covered despite its starting or ending point. Now let's see a figure here: AB equal to 4 meter, BC equal to 3 meter, AC equal to 5 meter. Distance here 12 meter because 4 meter plus 3 meter plus 5 meter equal to 12 meter. How is displacement defined? Displacement is defined as the change in position of an object. It is a vector quantity and has a direction and magnitude. It is represented as an arrow that points from the starting position to the final position. For example, if an object moves from A position to B, then the object's position changes. This change in position of an object is known as displacement. Now let's say figure here: displacement of A is 0. Distance versus displacement. The complete length of the path between any 2 points is called distance. Displacement is the direct length between any 2 points when measured along the minimum path between them. Distance is a scalar quantity as it only depends upon the magnitude and not the direction. Displacement is a vector quantity as it depends upon both magnitude and direction. Distance can only have positive values. Displacement can be positive, negative. What is velocity? The meaning of velocity of an object can be defined as the rate of change of the object's position with respect to frame of reference and time. It might sound complicated, but velocity is basically speeding in a specific direction. It is a vector quantity, which means we need both magnitude and direction to define velocity. The SI unit of it is meter per second. Whereas, velocity is of two types. One is uniform velocity and another is non-uniform velocity. Uniform velocity. The another name is uniform velocity is equal velocity. If the value and direction of velocity of an object remain unchanged with time, then the velocity of the object is called uniform velocity. Now let's see a figure. Here the particle cover the distances 0.25, 0.50, 0.75, 1.00, 1.25, 1.50 meter in 1, 2, 3, 4, 5, 6 seconds respectively. In the figure, time versus velocity is expressing the position of a moving particle along a straight line in the same direction by points one after one or serially. The distance of the two intermediate points in the direction of displacement is 0.25 meter. The particle covers the distance 0.25 meter per second. That is, the particle covers same distance in the same time. Therefore, it indicates uniform velocity and its value is 0.25 meter per second. Now I discuss about non-uniform velocity. If the velocity of a particle is different with time, the velocity is called non-uniform velocity. Now let's see a figure. Here, a particle crosses 4 meters in first second. Here the particle does not cover the same distance with the same time. Therefore, the velocity will be non-uniform velocity. Here, this curve represents a non-uniform velocity. But as you know, the another name is non-uniform velocity is variable velocity. What is acceleration? Acceleration is defined as the rate of change of velocity with respect to time. Acceleration is a vector quantity as it has both magnitude as well as direction. It is also the second derivative of position with respect to time, or it is a first derivative of velocity with respect to time. But as you know, acceleration is of two types. One is uniform acceleration and another is non-uniform acceleration. Uniform acceleration. If the magnitude and direction of acceleration of a particle remains unchanged, then the acceleration is called uniform acceleration. Say figure, here the velocities of a particle are 2, 4, 6, 8 meter per second at 0, 1, 2, 3 seconds respectively. Here the change of velocity is 2 meter per second. In uniform acceleration, the graph of time versus velocity is indicates a straight line. Non-uniform velocity. When the acceleration varies with time, it is called non-uniform acceleration. Here we see a graph which represents non-uniform acceleration. This curve represents a non-uniform acceleration. The increment diminution has been shown in time versus velocity by this curve. Resultant of several velocities. If several velocities act on a particle at a time, then their resultant is equal to a fixed velocity. The fixed velocity is called resultant velocity of several velocities acting on the particle. Suppose velocities v1, v2, v3 are acting at any particle at a time. If their resultant velocity is equal to velocity v, then resultant velocity v equal to v1 plus v2 plus v3. Now I discuss parallelogram law of velocities. Statement. If two velocities are acting in magnitude and direction on a point at a time along with two adjacent sides of a parallelogram, then the diagonal which passes through the intersecting points of that adjacent side will denote the resultant of the velocities in magnitude and direction. Here OACB is a parallelogram where OC is diagonal. The diagonal OC of the parallelogram indicates the resultant velocity in magnitude and direction. Magnitude and direction of the resultant of two velocities. For this, we use two figures, figure 1, figure 2. Now, suppose that the velocities u and v acting at the point O with an angle alpha indicated in magnitude and direction by OA and OB respectively. Now we draw the parallelogram OACB, OACB, OACB and join OC for first figure and OC for second figure. According to the law of parallelogram, the resultant of U and V is W, which is indicated by the diagonal OC. By diagonal OC in magnitude and direction. Draw the perpendicular line CD, perpendicular line CD from C to extended part of line OA in figure 1. In figure 1, extended part and on OA in figure 2. Since OB and SC are opposite sides of a same parallelogram, OB and SC are opposite sides of a same parallelogram, the velocity V denoted by OB and also by SC. In figure 2, OB and SC are opposite sides of same parallelogram. The velocity V is denoted by OB and SC. If the resultant W makes an angle theta with velocity U, the resultant W makes an angle theta with velocity U for figure 2 and 1. For right angle triangle COD, we apply Pythagoras theorem. Then we get OC square equal to OD square plus CD square, because we know hypotenuse square equal to base square plus perpendicular square. Here OC is hypotenuse, CD perpendicular and OD base. OD square equal to OA plus AD square and CD square remain same. Here OA plus AD for first figure, because OD equal to OA plus AD, and for second figure OD equal to OA minus AD. From right angle triangle CAD in figure 1, we get AD by SC equal to cos angle CAD, because we know cos theta equal to base by hypotenuse. Here AD base and SC hypotenuse. Cos angle CAD equal to cos angle BOA. You see in the figure that BOA equal to alpha. So finally we can write cos alpha. Using first and last term, we get AD equal to cos alpha. AD equal to SC cos alpha equal to V cos alpha. And CD by SC equal to sine angle CAD equal to sine BOA equal to sine alpha. Similarly, CD equal to SC sine alpha equal to V sine alpha. From right angle triangle CAD in figure 2, AD by SC equal to cos angle CAD. Angle CAD equal to pi minus alpha. CAD equal to pi minus alpha equal to minus cos alpha. Or AD equal to minus SC cos alpha equal to minus V cos alpha. And CD by SC equal to sine CAD equal to sine pi minus alpha equal to sine alpha. Finally, we get Ct equal to S sine alpha equal to V sine alpha. Magnitude. Here OC square equal to OA plus minus AD square plus CD square. Using the value of OC, OA, AD and CD, we get W square equal to U plus V cos alpha plus V sine alpha square. Here using A plus B whole square formula, we get U square plus 2UV cos alpha plus V square cos square alpha. Here V square sin square alpha remains same. From last two term, take common V square, then we get V square first bracket cos square alpha plus sin square alpha. But as you know, sin square alpha plus cos square alpha equal to 1. If we multiply V square by 1, you get V square. So finally you get U square plus 2UV cos alpha plus V square. Using square root, we get W equal to root over U square plus V square plus 2UV cos alpha, which is our required magnitude of two velocities. Direction. We use two figure. If the resultant W makes an angle theta with U, resultant W makes an angle theta with U. For second figure, resultant W makes an angle theta with U. For right angle triangle COD, we get tan theta equal to CD by OD, because you know tan theta equal to perpendicular by base. Perpendicular here CD and base OD. Finally, we get tan theta equal to CD by OD. CD remains same here. OD equal to OA plus minus AD. For first figure, we get for OD equal to OA plus AD, and for second figure, we get OD equal to OA minus AD. Putting the value of CD, OA, and AD, we get V sin alpha by U plus V cos alpha. Finally, we get theta equal to tan inverse V sin alpha by U plus V cos alpha, which is our required direction of two velocities. Homework. Find the magnitude and direction of the resultant of two velocities for different cases. Maximum result for two velocities, minimum result for two velocities, result of two orthogonal velocities, result of two equal velocities. But due to corona pandemic, everything is stopped. So how to protect yourself? Follow these easy steps to help prevent the spread of COVID-19. Disinfect surfaces around your home and work. Wash your hands for at least 20 seconds. Cover your mouth when sneeze or cough. Try to keep distance. By this, you can save yourself. Thank you.